Hello people, today we'll be solving LeetCode daily question 2742, which is painting the walls. It is a hard level dynamic programming question, and in this we'll be given two zero index integer array, cost and time, and of size n, and it is given that of size n representing the cost and the time taken to paint n different walls respectively. It means that we have to in total paint n walls. Okay, and will be two painters available. A paid painter will print the wall in ith time, and it will take the cost of I units now that money, and a free painter will paint any wall in 1 unit of time at cost 0, but the free painter can only be used if paid painter is already completed or is already occupied. Okay, so we have to return the minimum amount of money which is cost we are required to paint and watch. Okay, so let's move to the explanation of the test cases. It is given that in example 1, let's say the cost is given this and time is given this. So if we pick the values at index 0 and 1, it means that the cost will be like, let's say the values at 0 at 1 index are painted by the paid painters, and these will cost us 1 and 2 units, and the time taken will be of total 3 units. Okay, cost and time will be same. So and then we can do the free painter paints the wall at the second index and the wall at the third index, so that will cost us 0. So at the end that our total cost would be 1 plus 2, that is 3 units. And similarly in the other test case we are having 2 3 4 2 and time is 1 1 1 1 1. Okay, so what we can do, we can simply choose that the paid painter will be painting this 0th index wall and the third index wall, and free painter will be painting first and second index wall. Okay, so what we can basically observe that we have to choose the wall that takes minimum cost and then and the wall that are taking a high cost in for painting, that will be painted by the free paint. Okay, so at the end if we choose 0 and third index, our total cost comes out to be 4 units. Okay, so let's move to the how to solve this question. What we can do, we can basically solve it using top-down dynamic programming, and okay, let's start with that. uh, okay, so yeah, just a second. Yeah, okay, so let's have a DP array. DP, and we'll be having it in global scope. Then we are having what's the function? Paint walls. Okay, paint walls, and then we'll be having a cost array and time array as the inputs. Okay, so just a second. So yeah, okay, and then what we'll do n equal to length of cost, and then we'll be initializing dp with n and n plus 1. Okay, so and then what we'll be doing, we'll be simply calling, let's say, function whose name is solve with 0 and cost and time. Okay, so this would be the first function. Now let's write the solve function. It takes inputs as, okay, solve, it takes inputs as inti, like which index we should choose to paint or no, to paint the wall, and how many walls are remaining. At the end, in the starting we have to paint all the n walls, so we'll be having n, and then we are having simply the cost array. Okay, cost, and then we are having the time array. Okay, so let's set the basis that if uh, remain is less than equal to 0, what we'll do, we'll simply return 0. Okay, this means that all the walls have been painted. And then if I is equal to n, what we'll do, we'll simply be returning 1e9. Okay, this means that we'll be returning a maximum value because we have to find the minimum cost to check that the to find the minimum cost. Okay, so we'll be returning maximum value, and then what we have to do, we'll be checking that if dp and dpi remain, okay, here it should be, yeah, is not equal to 0. What we'll be doing, we'll be returning dpi remain. Okay, and then we'll be having two choices, that whether we choose to paint. If we choose to paint, then what we can do cost I plus dp plus solve function. Okay, uh, I plus 1 and remain -1. Okay, remain -1 minus time I, because we'll also be checking the time taken to paint that wall, and then simply cost and then time. Okay, so other choice is that if we don't paint. Okay, then what we'll be doing, we'll be just simply calling the solve function for I plus 1, and remaining will be the same, and cost and time. Okay, so at the end what we'll be doing will be in the dp I remain, we'll be filling it with minimum of paint or don't paint. Let's say we are starting with the index 1, so we'll be having two choices, that if we paint it by using the paid painter, or we paint it by using the free painter. Okay, we'll be just simply doing this, and after that we'll be returning dpi remain. Okay, so yeah, this was how the question should be done, and now let's move to the coding window. Firstly, let me zoom in. Yeah, here let's declare a dp array. Oh, okay, declare it in global scope only, int dp. Okay, in dp, and then what we'll do n should be equal to cost dot length, and dp would be equal to new int of size n plus 1. Okay, so after that what we'll be doing, we'll be returning this solve function with starting with 0, and we are having currently remaining n walls, and simply passing the cost and timer. Okay, now let's declare the function as private. It will be returning as an integer value, solve int I comma int remaining walls comma int cost array comma int time array. Okay, so firstly the basic is that if remain is greater than equal to 0, is less than equal to 0, we'll be returning 0, and then if I is equal to n, what we'll be doing, we'll be simply returning 1e9. Okay, then we'll be checking that if dpi remain is not equal to 0, we'll be simply returning dpi remain, and then we'll be checking that we'll be having two choices, that if we paint equal to cost taken by I plus solve I plus 1th index, and remaining would be -1 to be one based indexing, and time I. Okay, and then simply cost and time parameters. Okay, and then we have the choice to don't paint. Okay, don't paint that wall, so simply we'll be doing dp I plus 1, remaining would be same, and cost and time. Okay, so at the end we'll be putting dp, okay, we'll be just simply returning dp I remain is equal to map dot min paint comma don't paint. Okay, now let's submit it. Okay, it says cannot find n. Okay, let's declare here n here also. And the n. Okay, this not, okay, n is equal to the cost dot length, and this not n is equal to n. Okay, okay, I don't need to do this. I just simply can do this. Yeah. Okay, if possible. Okay, I just need to here do the type conversion and other array. Oh, okay. Here it should be here it should be solve. Yeah. So yeah, it's accepted, and now just simply submit it. So yeah, it's accepted, but if we see the time complexity for this code, it would be pretty high. Let's see, I guess time complexity would be of this type. We'll be making n into m recursion calls. Okay, and let me analyze it. And then okay, here and into, oh sorry, n into n recursion calls, and the space complexity would be, because we'll be using an dp array, so it would be a 2D array, basically n into n again. Okay, so this is not a very good time complexity. We can reduce this time complexity by using the space. Okay, first let's move with this tabulation method. Okay, so in case of tabulation, what we'll be doing, we'll be again declaring n equal to cost dot length. Okay, length. Okay, let's, yeah, paint walls. It will be having cost and time as the parameters. Okay, so then n, okay, n would be equal to length of cost, and then we'll be declaring a dp array of size n plus 1, and here also of size n plus 1. Then we'll be starting to iterate from for I equal to 1 to I less than, or I less than equal to n. And okay, and here what we'll be doing, we'll be filling in the dp array with dpn I with the maximum value. Okay, let's do that. Okay, we can do the type conversion in the coding window 1e9, putting with filling it with maximum value. So then we'll be having I equal to n minus 1, because we'll have to check how many walls are remaining. and I greater than equal to 0. Okay, so in this we'll be having another nested for loop for I equal for, okay, remaining, let's call it remaining walls equal to 1 to n. Okay, to remain less than equal to n. Okay, and then again we'll be having to choose two choices. We choose to paint. If we choose to paint, then we'll be doing cost I plus dp I plus 1, and then we'll be, for this index we'll be checking that maximum of 0th index or remaining minus 1 minus 9y. Okay, so this is how we can find that we want to paint, or this is how we'll be calculating the cost for painting a particular wall. And let's say we don't want to paint that particular wall, what we'll be doing, dp of y plus 1, and because the remaining walls will be same, so we'll just be putting the value of remaining. Okay, and at the end what we will be doing, dp I remain would be equal to minimum of paint or don't paint. Okay, so this is how the for loop will work, and after this we'll be simply returning dp 0 n. Okay, to paint the nth wall we'll be having its value at the 0th corner. Okay, uh, and so now okay, so sorry, so for painting the nth wall we'll be having the value in the 0th row at the nth column. Okay, so now let's move to the coding part for this. Let's reset it, and what we'll do, we'll again do n equal to, let me zoom in once again. Mm, okay, yeah, it's fine. Now n equal to cost dot length and int dp equal to new int n plus 1 n plus 1. So then we'll be filling in the dp array with I equal to 1, I less than equal to n, I plus plus dp n. The last row will be filling it with maximum value. Okay, and let's do the type conversion. Int 1 e9. Okay, so this is how the first for loop, and then we'll be for int I equal to 1, I less than equal to remaining, oh sorry, I equal to n minus 1, because we'll be checking I greater than, okay, here I greater than equal to 0, I minus minus, and then here then for and remaining, let's call it remaining equal to 1, remain less than equal to n, remain plus plus, and we'll be doing int paint should be equal to cost at I plus dp I plus 1, and here math dot maximum of 0 comma remain minus 1 minus time I. Okay, it's going a little bit out of the screen. Okay, let me fix that issue first. So yeah, okay, and then we'll be having simply the don't paint one. Okay, don't paint would be equal to dp y plus 1, and the remaining would be still the same. So at the end we'll be putting dp I remain would be equal to minimum of paint and don't paint. Okay, so after the for loops we'll be returning dp 0, okay, here, and I guess this should work. um, it says to don't paint. So yeah, this also works. So let's submit it. Yeah, as you can see that its time complexity is much better. uh, okay, so but its memory is not that good. So for the memory space optimization, what we can do, uh, okay, so first talk about the time complexity. uh, Actually the time complexity would be of n square only. Okay, okay, in this part I'll tell you one thing, that here the time complexity would not be of n into n alone. It would be for the checking all the conditions, but we'll be also using some space in the stack, so that memory will also be counted, and that will reduce our time complexity. Okay. uh, okay, here time complexity will be same n into n, and but here we'll not be doing any recursive calls. Because we are using the tabulation method or bottom-up dynamic programming. So there will be no recursive calls for the checking of the solution. So space complexity will just be n into n. Okay. So now let's move to the space optimization part, and what we can do. Okay. Again, yeah, paint walls with cost array and time array. Okay. So what we can do, n would be equal to length of cost, and we'll be having dp with value I have n plus 1 and prev dp of size n plus 1. Okay, so then what we'll be doing, we'll be just filling prev with the maximum value, again that is 1e9. Okay, and then we'll be setting prev 0 should be equal to 0. Okay, and now let's move to the for loop. For I equal to n minus 1, the for loops would be running the same. To I greater than equal to 0, then we'll be declaring dp once again, dp of size n plus 1, and then the for loop remain equal to 1 to remain less than or equal to n, remain plus 1. Okay, remain plus yeah. So for that dp, okay, let's find the painting cost. Okay, paint would be again equal to cost at I plus prev. Because in that also we in this case we were using the value from the I plus 1th index, and we are have already stored that value in the prev array, so we don't need to calculate it. So we'll not be needing a 2D array, because then after calculating the value we'll not be using that again. We'll just be using that for the index that is just for the row that is just above that particular row. So what we can do, okay, let me explain properly. Let's say we'll be having this array, let's call it prev, okay, of size 1 2 3, yeah, 5. Let's this is prev. Okay, this is prev array. and we'll be having similarly DP array, sorry for the drawing, of size 1, 2, 3, 4 and 5. Okay, and this is DP. Okay, so as in that case, what we were doing to check, uh, this is for this case. Okay, so what we'll be doing, we'll be, for calculating the value at this index, we'll be checking the value at this index, and then we'll be using the value to calculate the pace of the cost of painting at that particular index. Okay, so yeah, max of 0 comma remaining uh, -1 minus time I. Okay, so if we choose to don't paint, what we'll simply do, we'll update it with pref of remaining. Okay, and at the end we'll be doing dp I would be equal to minimum of paint don't paint. Okay, and after the execution of the inner for loop, we'll be just updating prev equal to dp. Okay, and then we'll be returning dp 0. Oh, sorry, dp n. Yeah. Okay, this is how that would work. Let's move to the coding window once again, and reset it, confirm. So yeah, let's do it again. And n equal to cost dot length and dp array equal to new int n plus 1, prev array which would be equal to new int n plus 1 once again, and we'll be doing the ars dot fill function, ars dot fill prev comma, we'll be typecasting the value. Okay, 1e9. Okay, and then we'll be setting prev 0 equal to 0. Okay, then for int I equal to n minus 1, I greater than equal to n, I greater than equal to 0, I minus minus. And then we will be initializing the dp array once again, new int in plus 1 for int remaining equal to 1 to remain less than equal to n remain plus plus. And what we'll be doing, we'll be checking the for painting cost. For a painting, that particular wall would be equal to cost at I plus prev math dot max of 0 comma remain minus 1 minus time I. Okay, and then for do not painting, uh, don't paint, we'll be just updating with the previous remaining walls. Okay, it should be paint, yeah, previous remaining walls, and then we'll be just doing dp remaining. Oh, okay, I guess here I made a mistake. Yeah, here it should be dp remaining. Okay, so because we need to calculate it for the remaining part and not for the ith part, yeah, dp remain will be equal to minimum of paint or comma don't paint. Okay, and after this we'll be setting prev equal to dp, and then we'll be simply returning dp and it will return the cost of minimum cost of painting the n walls. Okay, so let's submit it. As you will see, okay, it's an error. what's that is that legal start of expression. Oh, okay. So my bad. Yeah, yeah, and it's accepted. And now let's submit it. So yeah, as we can see, it beats in memory also and time also. So yeah, this was the solution and the optimized solution for this. So that's it for today. Thank you for watching.